Welcome to the next session, my dear friends. In the previous session, we have discussed up to the question number 15. So we are continuing the same. So it is 2.2 quality parameters of water. The topic name is quality parameters of water. Question number 16. As per your worksheet, it is GATE 2003 2 marks question. GATE 2003 2 marks question. So let us read out the question. So it was a table format was given. Concentrations of different cations were given. Sodium concentration, magnesium concentration, calcium concentration, and potassium concentration is given like this. What is the hardness of water sample in mg per liter as CaCO3? So what is the given data? The given data is Na plus concentration is how much? So cation concentration in mg per liter and equivalent weights. Equivalent weight was given. So sodium concentration is how much? 40 mg per liter and its equivalent weight is 23. Next is calcium mg plus 2. Its concentration is 10 and its equivalent weight is 12.2. And calcium 55 and its equivalent weight is 20. Potassium, it is 2 and its equivalent weight is 39. So these are the concentrations of different cations. So hardness, again I am saying the same thing. Hardness is caused due to multivalent metallic cations. See why I write again and again, you know. I want to make you to revise this because these statements are very, very important. These are the basic statements. What is meant by hardness? This is a basic definition. Why I write again and again is just to make this to enter into your brain completely. You never forget this. That is what is my intention. Why I write again and again. Okay. So here, so what are the multivalent cations? What are the multivalent cations here? The multivalent cations are Mg2 plus and Ca2 plus only. Potassium is not a multivalent cation and sodium is also not a multivalent cation. So these two are the multivalent metallic cations. So these two only causes. So total hardness, we know the formula of total hardness in mg per liter as a CaCO3 is equal to Ca2 plus concentration in mg per liter into equivalent weight of CaCO3 by equivalent weight of Ca2 plus Mg2 plus concentration in mg per liter multiplied with equivalent weight of CaCO3 by equivalent weight of Mg2 plus. So here using this formula, total hardness as CaCO3 is equal to Ca2 plus concentration is how much? 55 into what is the equivalent weight of CaCO3? 50 by equivalent weight of Ca2 plus already here given and we also know it is 20 plus Mg2 plus concentration is 10 in mg per liter into equivalent weight of CaCO3 is 50 and the molecular weight equivalent weight generally we take approximately it is 12 but it was given 12.2 here, take it as 12.2. So this is the answer. So if you solve this, you will get the total hardness. Let us see what is the answer. So if you solve this, you will get 172 mg per liter. You will get 172 mg per liter. So this is the answer. Simple question. I told you already, in this topic majority of the questions will be coming from total hardness and total alkalinity only. Okay, so this formula and other formula of total alkalinity, if you remember these two, then you can easily do majority of the questions comes out of this chapter. Okay. Next, question number 17. Question number 17 and question number 18 are common data questions. Question number 17, question number 18 is common data, 2003 4 marks. So in 2003, from the same topic, we got 6 marks. Okay, 2003, question number 17 and 18. Question number 17, let us see first. This is a common data. A water treatment plant. Okay, see, this question is actually 17 and 18, it is dependent on treatment of system. So we will discuss this later after the discussion of alum and all. Question number 17 and 18 we will discuss later. Okay, because this concept is not relevant to this chapter, but it was given here. Anyways, we will discuss this. Excuse me. Anyways, we will discuss this in the next coming topics. Okay, because we didn't discuss the concept of this yet. Next is question number 19. Question number 19, again 2003 2 marks. Question number 19. So many questions came from environment in 2003. Question number 19. See, in question number 19, there are two lists given, list 1 and list 2, type of water impurity and method of treatment. So list 1 is A, hardness. List 1 is A, hardness, and B, brackish water from C. Brackish water from C, and residual MPN from filters. Residual MPN, that is most probable number, from filters. And D, turbidity. In list 2, they have asked method of treatment. Actually, this is also after treatment only we need to discuss, because we didn't discuss the treatment processes yet. Okay. So anyways, I can explain this here also. So the first one is reverse osmosis. Reverse osmosis. And second option is chlorination, zeolite treatment. Chlorination. And the third one is zeolite treatment. Zeolite treatment. And fourth one is coagulation and flocculation. Coagulation and flocculation. And fifth one is coagulation, flocculation and filtration. I think there is some mistake here. Let us see the options. See, hardness, generally we remove hardness using, I told you yesterday in the previous sessions, there are three methods: lime soda, zeolite method and demineralization method. By these methods we remove the hardness. So hardness can be removed by this method. See, brackish water from sea, generally we use reverse osmosis method for this. We will discuss in detail what is meant by reverse osmosis method and all in the miscellaneous treatments topic, okay? So that we will discuss at the last. And residual MPN of the filters, generally it is removed by chlorination. So MPN, disinfection, that means MPN means what? Microorganisms. So microorganisms will be disinfected by chlorination. So that is chlorination. Turbidity, I hope this is not, I think it was a printing mistake. It is coming from another question. So turbidity, okay, turbidity can be removed by coagulation and flocculation, and the next one is filtration. Okay, fifth option, coagulation and flocculation and filtration, followed by filtration. See, this turbidity, generally we use this method, coagulation, flocculation, filtration, for the removal of turbidity. So for A it is 3. So there and for B it is 1. 3, 1. So option is D is the option. So for D it is 5. So that means this is 5. Only this is wrong. So if you do coagulation and flocculation, after the treatment, filtration is also needed. Otherwise we cannot remove this turbidity. Okay, that is why coagulation and flocculation followed by filtration is needed for the removal of turbidity. Okay, so that is question number 19. Let us go to question number 20. Question number 20, GATE 2005, 2 marks. Question number 20. GATE 2005, 2 marks. So if the tomato juice is having a pH of 4.1, the hydrogen ion concentration will be. So he has given that. So pH was given of tomato juice. pH was given as 4.1. So for tomato juice, pH is given as 4.1. Then what is H plus ion concentration? Very simple question. But he is asking in mole per liter only. Then it is very simple. Hydrogen ion concentration will be. So here H plus ion concentration is nothing but this is equal to minus log of H plus ion concentration. So that means H plus ion concentration is nothing but 10 to the power of minus 4.1. Okay, 10 to the power of minus 4.1. That can be written as 10 to the power of minus 5 plus 0.9, right? 10 to the power of minus 5 plus 0.9. So here I can write this as 10 to the power of 0.9 into 10 to the power of minus 5 mole per liter. This is also mole per liter. Okay, so this is the answer actually. If you solve 10 to the power of 0.9, then you will get some value. So that is equal to 10 to the power of 7.94. this is equal to 7.94 into 10 to the power of minus 5 mole per liter. This is the answer. So that is question number 20. Question number 21. Question number 21. So it is GATE 2006 1 mark. GATE 2006 1 mark. Question number 21. So here a synthetic sample of water is prepared by adding 100 mg kyonolite, that is clay mineral, and 200 milligram of glucose, 168 milligram of NaCl, and 120 milligram of MgSO4, 111 milligram of CaCl2 to 1 liter of pure water. The concentration of total solids and fixed dissolved solids respectively in the solution in mg per liter equal to, see here, what are the solids, different solids. Solid kyonolite, first one is kyonolite, it is 100 grams, 100 milligrams, okay, and next is glucose, 200 milligram, glucose 200 milligram, and NaCl 168 milligram, and MgSO4 120 milligram, MgSO4 120 milligram, and CaCl2 111 milligram, okay. See here, let us classify the solids first. This is fixed solid, fixed inorganic solid, So this is dissolved solid, generally glucose, dissolved solid, dissolved organic solid. So dissolved organic solid, organic means what? Volatile. Organic means volatile, inorganic is not volatile, okay, it is fixed. But it is in suspension form, it is suspended. It is not a dissolved solid. NaCl again dissolved, inorganic. So that is fixed. Fixed but dissolved, okay. This is also dissolved inorganic solid, again this is also fixed. And this is also dissolved inorganic solid which is fixed. So total solid means everything is a solid. So total solid is this. Total solids is how much? So it is 9, 6, again 9, 6, 2, 8, 9. So this is again 699. So 699 mg is a total solid. 699 mg is total solid. And the second one is fixed dissolved solids. Fixed, this is fixed but not dissolved. Suspended, that is suspended. This is also fixed solid but suspended. So fixed dissolved, this is dissolved but not fixed. Okay, fixed dissolved solids are these three. These three are the fixed dissolved solids. Okay, so this one is organic. Organic means volatile. It is also dissolved solid but not fixed. It is volatile. Okay, so these are the fixed dissolved solids, these three. So 699 minus 300. These two are not dissolved, fixed dissolved solids. So that is why fixed dissolved solids, fixed dissolved solids is 699 minus 300, that is 399. In your solution it was given wrong, it was given as 599, it is wrong, it is 399 not 599, because glucose is also a dissolved solid but it is volatile, not fixed. Okay, so that is the answer for the 21st question. So let us go to the question number 22. Question number 22 and 23, 4 marks questions. It is common data question, 4 mark. Question number 22 and 23. So let us see first question number 22. A water contains the following dissolved ions. The dissolved ions are given like this. Na plus, so given data, Na plus is 56 mg per liter, Na plus 56 mg per liter, and Ca2 plus 40 mg per liter, Mg2 plus 30 mg per liter, and Al3 plus 3 mg per liter, and HCO3 is 190 mg per liter, and Cl minus is 165 mg per liter, and pH is 7. Okay, so atomic weights were given for all the materials. Atomic weights were given. For calcium the atomic weight is 40. Okay, for magnesium the atomic weight is 24, and for aluminum the atomic weight is 27. For aluminum the atomic weight is 27, and for hydrogen it is 1, and carbon it is 12, oxygen it is 16. All these thing data is not needed for us because we already know all the weights and all. Okay, so first question is, what is the total hardness of the sample? Total hardness. So total hardness is caused due to what? Total hardness is caused due to multivalent metallic cations. So where are the multivalent metallic cations? Multivalent metal. Okay, multivalent metal. Okay, So this is not a metal and it is not a cation. This is not a metal, this is not a cation. This is not, it is a metal but it is not it is not a multivalent. Okay, so now, so there are 3, 1, 2, 3. These are the multivalent metallic cations. So total hardness in mg per liter as CaCO3 is equal to, so Ca2 plus concentration into equivalent weight of CaCO3 by equivalent weight of Ca2 plus Mg2 plus multiplied with equivalent weight of CaCO3 by equivalent weight of Mg2 plus Al3 plus into equivalent weight of CaCO3 by equivalent weight of Al3 plus. So this is the formula of total hardness. So how many multivalent metallic cations are present? So all the multivalent metallic cations we need to consider. Okay. Here there are 3 multivalent metallic cations. So I am considering all the 3. So total hardness in mg per liter as a CaCO3 is equal to Ca2 plus concentration is 40 into what is the equivalent weight of CaCO3, 50 by equivalent weight of Ca plus is 20 plus Mg2 plus concentration. Mg2 plus concentration is 30 multiplied with equivalent weight of CaCO3 is 50 and equivalent weight of Mg2 plus is 12 plus Al3 plus concentration is 3, though it is less we need to take because it was given. So it is 3 into equivalent weight of CaCO3 is 50. What is the equivalent weight of Al3 plus? So equivalent weight of Al3 plus, this is atomic weight. Okay, molecular weight will be, this is atomic weight, molecular weight means double. So 27 plus 27, that is 54. 54 by 3, that is 18. Okay, 54 by 3, that is 18. So equivalent weight of Al3 plus is equal to, equivalent weight of Al3 plus is equal to equivalent weight of Al3 plus is equal to 27 into 2 is the molecular weight because 27 protons and 27 neutrons. So 27 into 2 is the molecular weight, that is 54 by 3. 3 is the valency. Okay, the 3 is the valency. So it is simply 18. 18 is the answer. So 18. So if by solving this equation, we will get the total hardness. By solving this equation, so we will get the total hardness. So that is equal to, okay, here it is molecular weights only. 27 is the molecular weight, not atomic weight, it is molecular weight. Directly we can take it. Because see, 40 is the molecular weight, 24 magnesium is also molecular weight, 27 is also molecular weight. So 27 by 3, that is 9. Okay, 27 by 3, that is 9. That is not atomic weight, that is molecular weight. Okay, so it is equal to 241.67 mg per liter, which is equal to 242. Approximately it is equal to 242. Okay, this is the total hardness. And now next question is question number 23. Question number 23 is the same data. Using the same data, we have to do the question number 23 also. He is asking non-carbonate hardness. So non-carbonate hardness, for determining the non-carbonate hardness, first we need to determine the alkalinity. So if you know the alkalinity, then only we can determine the non-carbonate hardness. Okay. So alkalinity means we need to look at the concentrations of carbonates and bicarbonates. So it was already given. Question number 23. So the non-carbonate hardness. So before going to non-carbonate hardness, what is total alkalinity here? Total alkalinity in mg per liter as CaCO3 is equal to, see here, there is only HCO3, there is no carbonate, only bicarbonate is present. So using bicarbonate we will measure the carbonate hardness. Okay, using bicarbonate only we will measure the carbonate hardness. It is equal to, total alkalinity is equal to, actually CO3 2 minus concentration in mg per liter into equivalent weight of CaCO3 by equivalent weight of CO3 2 minus plus HCO3 minus in mg per liter into equivalent weight of CaCO3 by equivalent weight of HCO3 minus. This is the formula. Okay, so but here CO3 2 minus concentration is 0. CO3 2 minus concentration is not there. So that is why we can take this as 0. So simply total alkalinity in mg per liter as CaCO3 is equal to simply HCO3 minus in mg per liter multiplied with equivalent weight of CaCO3, that means 50, it is 50 by equivalent weight of HCO3 minus, that is 61. So what is the concentration of HCO3? HCO3 minus was given as 190 into 50 by 61. So what is the value of this? The value of this is equal to 155.73 mg per liter as CaCO3. So this is carbonate hardness. What he is asking, non-carbonate hardness. This is carbonate hardness. Okay. So generally the carbonate hardness is nothing but the minimum of total alkalinity and total hardness. The minimum of total alkalinity and total hardness. What is total hardness? Total alkalinity. So that means minimum of 242 and 150. Where is this? 156. Okay, so that means 156 is the carbonate hardness. Okay, 156 is the carbonate hardness. So carbonate hardness is equal to 156. Carbonate hardness is equal to 156. Non-carbonate hardness is equal to total hardness minus carbonate hardness, which is equal to 242 minus 156. 242 minus 156, which is equal to total hardness is equal to 242 minus total non-carbonate hardness is equal to 242 minus 156, which is equal to how much? It is 86 mg per liter. 86 mg per liter as CaCO3. 86 mg per liter as CaCO3. Okay, 86 mg per liter as CaCO3. That is question number 23. That is non-carbonate hardness. This is non-carbonate hardness. So in the previous question we have determined the carbonate hardness. Okay, we have determined the carbonate hardness. Let us go to the next question. Question number 24. Question number 24. GATE 2007 1 mark question. Question number 24, GATE 2007 1 mark question. So majority of the questions from this topic, they come from this total hardness and total alkalinity only. So if you are strong enough in these formulas of total hardness, total alkalinity, carbonate hardness, non-carbonate hardness, then it is very easy for us to solve any kind of question. Only knowing these formulas is very, very important. So rest of the thing is very easy. So if you know the formula, simply substitute the data given, and you need to be clear about the basic concept. What is meant by hardness exactly, and what is meant by alkalinity. So if you need to be clear about the basics of these two, and how to find carbonate hardness, non-carbonate hardness is also very, very important. So the next question, question number 24, 2007 1 mark question. 2007 1 mark question. The presence of hardness in excess of permissible limit causes. So what is the question? Excess hardness causes. Excess hardness causes majorly increases the soap consumption. Increases the soap consumption. Imparts bitter taste. Imparts bitter taste to water. And scaling of boilers. Scaling of boilers. So these are the major problems associated with excess amount of hardness. So here the options are given like this. Cardiovascular problems, option A, which is not correct. Skin discoloration, which is also not relevant. Calcium deficiency is also not relevant. And the option D, increases laundry expenses. See, increasing soap consumption indirectly increases the laundry expenses. So that is relevant to this question. So excess hardness causes increase of laundry expenses. Okay. And next question number 25. It is also 2007 1 mark question. Question number 25. Question number 25. 2007 1 mark question. So the alkalinity and the hardness of water sample are 250 mg per liter and 350 mg per liter as CaCO3. Alkalinity was given as alkalinity. So given that the alkalinity is equal to how much? It is 250 mg per liter. And hardness, and the hardness is given as 350 mg per liter. Hardness 350 mg per liter. Hardness is 350 mg per liter. So Which of the following is correct? Option A, 350 mg per liter is, first of all, we need to determine the carbonate hardness and non-carbonate hardness here. See, carbonate hardness is equal to minimum of alkalinity and hardness. Minimum of alkalinity and hardness, that means, so minimum of alkalinity is how much? 250 mg per liter and hardness is 350 mg per liter. So the minimum value is 250 only. So carbonate hardness is equal to 250 mg per liter, and non-carbonate hardness is equal to non-carbonate hardness NCH is equal to total hardness minus carbonate hardness, that is equal to 350 minus 250, that is equal to 100 mg per liter. 100 mg per liter. So from this data we can derive that carbonate hardness is equal to 250 mg per liter and non-carbonate hardness is equal to 100 mg per liter. So now let us see the options. First option is saying that 350 mg per liter is carbonate hardness, which is wrong. Only 250 is the carbonate hardness. And second option is saying that 250 is the carbonate hardness and 0 non-carbonate, which is wrong. 0 is not the non-carbonate value, 100 is the value. So third option is also wrong. Fourth option, if you see 250 mg per liter carbonate hardness and 100 mg per liter non-carbonate hardness, which is correct. So option D is correct. Okay. So next question is question number 26, 2008 2 mark. 2008 2 mark. (2008) 26. Question number 26, 2008 2 mark question. Okay. So let us read out the question. A wastewater sample contains 10 to the power of minus 5.6 millimole. See, a small m, if you miss, then it changes the answer. 10 to the power of minus 5.6 millimole per liter of OH minus ion concentration, then pH of the sample. So given data is, so the pH value is, the wastewater contains, so OH minus ion concentration is given, OH minus ion concentration 10 to the power of minus 5.6 millimole per liter. Majority of the people may miss this. They treat that it is a printing error, typo error. So there won't be any typing errors in GATE examination. So everything is printed intendedly. Okay. So that is here this is millimole per liter. So that means the concentration in mole per liter will be 10 to the power of minus 5.6 into 10 to the power of minus 3 mole per liter. That means it is equal to 10 to the power of minus 8.6 mole per liter. 10 to the power of minus 8.6 mole per liter is the OH minus ion concentration. Now he is asking pH. Okay. pH is asking. Let us find POH. So now POH is equal to, so minus log of OH minus ion concentration. Okay. So that means it is equal to 8.6. So this is POH. Then pH is equal to, so 14 minus POH, as since pH plus POH is equal to 14. We know this relationship already. So POH, if I know, then pH is equal to 14 minus POH. That means 14 minus 8.6, that is equal to how much? 13 minus 8, 5.4. 5.4 is the answer. Okay, 5.4 is the answer. So this is question number 26, GATE 2008 2 marks question. So we will discuss the rest of the questions in the next session. Thank you so much.